Hi everybody, I'm the greatest living inventor, and today we are doing my invention, Rattlesnake Armageddon. Let me write it down. I don't have my board, my whiteboard, so I'm writing it on paper, and I'll show you each time after I'm writing it. Rattlesnake Armageddon. Okay, so this is our title. Okay, so this invention is because Israel is now under attack by Hamas, and they are hiding, the terrorists are hiding inside the underground, under Gaza, and they are protected by tunnels, like they are inside tunnels. So the Armageddon part is because if you remember in the movie Armageddon, Quincy, the scientist, says we cannot blow it from the outside, but we can blow it from the inside. Like he gives an example with if you have a firecracker and your hand is open, then it just burns your hand. If you close your hand, so it's from the inside, then you blow up your hand. So this is basically what we are doing, but I'm giving the whole process of how do we detect, like map out exactly where the tunnels are technically. How do we find out, how do we and how do we destroy the tunnels. Okay, so and we'll see that it's connected, like part of the detection is the destruction and the detection are combined. Okay, so this is our title, and first let me give you some specs, so you don't I didn't find the like detailed information about the tunnels, but basically it's the deepest one that they found so far is 70 meters in depth, and the length, I'm giving you what I assume to be the measurements of a tunnel based on the comparison that the Israel's army, the IDF, said that one tunnel could be, if the Palestinians were seeking peace, it could be 86 homes. So let's say a home is like I lived in near Tel Aviv, so it was an apartment with 20 meters, 20 square meters. So if you multiply 86 by 20, you get let's do it on paper. 86. So one tunnel. Try to do it in front of you so you'll see something. Equals 86 homes. Okay, so let's say each home is 20 meters. Okay, so 20 square meters, and this equals 1,720 meters, square meters. So square meters, and okay, and if we divide by, let's say, 4 meters. Okay, so tunnel's length is about this number divided by about 4 meters. That is what I'm assuming. Okay, so it's like the width of the tunnel, and this is about not about, like exactly 430 meters. Okay, so the length of the tunnel is 430 meters about, and the depth, as I told you, tunnel's depth is like we said, 70 meters. Okay, this is the worst case. And what else? So the width we are assuming to be 4 meters. Okay, and other than that, okay, so we have the length, the depth, the width, and also it's a straight thing. Okay, so it's not like it could be a little curved, but it doesn't have like a lot of turns. Okay, this is critical because if you've seen the episode in Mythbusters about the explosion inside the tunnel or a ditch, they said that in World War II the ditches were dug or the trenches were dug in I'm not sure if it's World War I or World War II, but in one of the world wars it was, the trenches were dug like in I'm not sure about the word in English, but it's like in angles. Okay, so it's like going this way, and then after a short time, after a short distance, going that way, and like in 45 degrees in like a pattern like this. Okay, so not like a straight pattern, but a pattern like this. But in Gaza, so this is like in World War I. Okay, but in Gaza, they built them straight, or it could be like something like this, but it's basically straight. How do we know? Because they built them originally for the movement of vehicles, especially motorcycles, inside, because they wanted to kidnap Israeli soldiers or Israeli civilians and travel fast to escape along the tunnel. So even if it has one curve or one corner, if you have a lot of corners, you cannot escape fast with a motorcycle. So this is good for us because it's an advantage for the Israelis, because if you make an explosion, okay, if you, let's say we detonate something, if it was like that, then if it's they have an explosion here, then it stops the air that blows away stops here. Okay, so it's like it cannot go around the corner. Okay, it stops here. But if you have straight or almost straight lines, then it continues. Okay, so I'm just looking for the word because I forgot to look for the exact word. 1 second. It's the word for the air that is blown because it's critical. Okay, the shock wave. Okay, so the shock wave. So shock wave. Can you see? Okay, so the shock wave here, it stops. This is the bomb, and here it's the shockwave stops and cannot continue this way and this way. And here the shockwave just continues along the tunnel. Okay, so it can progress along the tunnel. So in fact, if we can blow something inside the tunnel, then it goes all the way up to the next door, the next, to the end of this part of the tunnel, to the end of this section of the tunnel. Okay, so now that we know what we want to achieve, so we don't want to fight in the streets of Gaza. We want to fight. We don't want to fight. We want to automate, to make it automatic, mechanized, the fight underground, okay, inside the tunnels. Okay, so first, how do we locate, how do we map the tunnels? Where are the tunnels? Because it's like some of them are in open areas, some are under buildings like a school or something of children, and we cannot enter. Like, it's not something that the world will accept, that we will raise down, Israel will raise down a school and will dig out the entrance to the tunnel. So we cannot use the entrance, the normal entrance to the tunnel. So we need a place where the tunnel is far away from the entrance. Okay, so let's say I'm drawing you a picture of the tunnel. So if we have here a building, and here a building, and we have the tunnel, then we are not concentrating here. Okay, we don't care about here or here, the actual entrance. We care about any point in the middle. Okay, let's say here. Okay, we attack somewhere in the middle. Okay, so first of all, how do we know like where to begin? Okay, so remember what we said. The name of the invention is the Rattlesnake Armageddon. So the rattlesnake has this part, the rattle. We'll talk about the snake soon, but now we're talking about the rattle. So let's start a new page. Okay, so rattle. The rattle part I need to apologize. I should have apologized in the beginning. I need to apologize that all this invention is like, half-assed. It's not complete. It's not polished. It's not. I didn't check everything like I usually do. That I, think about it and think about it and like check and check. Here I'm just doing it in a rough way because time is an issue, and Israel is about to enter Gaza. So this is, I think now it's Wednesday, and the attack was in Saturday, so it's the fourth or fifth day of the war. And I cannot like take my time and take a few days to think about it. So I'm giving you the rough idea, but it's a solid idea, but it's a rough idea, like a sketch, and you, the experts, should make it like the final product. But it's working, it's just that I didn't iron out every little detail. Okay. If someone wants to contact me, you know where to contact me. You can contact me in my Twitter or whatever, and I'm available for helping you out with the details. Okay, so now we are talking about the rattle. So the rattle is basically using the same technology that that we use to detect an earthquake, okay? But we are using it to detect tunnels. How so? Once we make a, let's imagine that we look at the Gaza is all made out of sand, except the tunnels, I mean underground. All the ground except what is paved, concrete and buildings, but underground it's made of sand, except the tunnels, which are solid, like they are a hard material. It could be concrete, it could be iron, it could be a combination of those, but it's like a solid either metal or rock, concrete. So we use the fact that shock waves travel in a hard medium a lot faster and a lot stronger than in a soft material like sand. Okay, so if we have an area here, okay, let's say this is we are looking at a map of Gaza from above, of some area in Gaza. So this is one area. Okay, this is sand. Okay, and I'm not sure you can see what I'm writing. I have written sand. Okay, and this is another area that is sand. And if we have underground we have a tunnel, okay, this is sand, this is sand. And if we have, from some reason, some shockwave, like let's say we detonate something here, we detonate a bomb here, and the shockwave goes expands towards everywhere. It also expands to here, it also expands to here. But once it reaches this hard medium, then the shock wave prefers, okay, it's like quote unquote, but it actually physically prefers to go along something that is hard, like a dense hard medium. The shock wave travels a lot faster along this path. Okay, it's like a conductor for shock waves, like an electric conductor, but for the waves of the, instead of electromagnetic waves, so it's like a tunnel for the shock wave. Okay, so if you want to know more, you can look at my invention about the solution for an earthquake. Here we're using it in the reverse direction in creating an earthquake and detecting it here. We want to detect this earthquake. Okay, so here we have, I'm drawing it like it's an ear, but it's not really an ear, it's a detector, but I'm drawing it like it's a human ear. Okay, so it's like detector or sensor. Okay, so here we have the explosion, and here we have our ear or detector or sensor. Physically, we will talk exactly about what we mean, which sensor exactly to put, but which detector. But imagine we have an ear here, an ear here, an ear here. We drop from an airplane or a helicopter a few detectors, a few ears. Okay, we have an ear here and an ear. Okay, we have ears all over the place. Okay, cheap detectors, which I'll tell you about in a second. And the ones that hear the shockwave, that detect the shockwave, are the closest to the tunnel. Okay, so depending on the resolution that we spread the detectors, but we can have a good idea where the tunnel is. Okay, by how fast, I mean, if it's close, then it's the first one to hear it is the closest ones. Okay, so this one will hear the shock wave before that one, for example. Okay, so what are we talking about, like, now in a more exact sense? I'll tell you what it's called. It's called the detector. The detector is actually called, sorry, ADXL 335. Okay, ADXL 335, and you can buy it in Adafruit, which is like a firm, like a shop, for, okay, it's called a triple axis accelerometer. And it costs $14. Okay, so ADXL, sorry, ADXL 335 by Adafruit, and it's a triple axis accelerometer, and it's this price, $14. Okay. So you see it's a cheap equipment, and it's compatible with Arduino. Okay, our like brain of the whole system is called Arduino, and Arduino is like a controller, like a computer, but the bare minimum of a computer. Okay, so I'm sure you've heard of it. If not, then give it to an engineer and he would have heard of it. Arduino, this is our controller, our brain. Okay, and all the controllers connect to the Arduino. Arduino itself, it costs like $70 more or less. The expensive one, the Arduino Giga R1 Wi-Fi. Arduino Giga R1, sorry, R1 Wi-Fi is 69 euro. Euro is like dollars. Okay, so this is like the model and the price of the expensive one. Maybe you can get away with something that costs half of it. Okay, but of course each component, the whole system is much cheaper than someone of our soldiers who would get killed. Okay, so now let's talk about oh, and another thing, still in the detector, I want you to watch a YouTube video. Let's see how we're doing with the time. Okay, 28 minutes. That's a lot of time spent on talking about background, but we had to have the background just to know about, like, if we are talking with people in Israel, they know exactly what a tunnel is, but if we are talking about it in abroad, like if you show it to an American partner that needs to manufacture this or something, then you know, you need some backup. So a YouTube video which is called how to make earthquake detector at home. How to make an earthquake detector at home. Okay, and this is by the YouTube channel Inventor KR. Okay, so I'm just showing you this if you cannot understand my accent or something. A YouTube video, how to make earthquake detector at home, Inventor KR. This one really, like, this is the bare minimum of making a detector. It's really cool. It gives a PCB card, like a breadboard, and he shows you exactly which resistor, which, and he has like a spring with a metal ball. So it's like you don't even need an Arduino controller. It's just the cheapest way, okay? And I guess this one costs a few dollars, like a handful of dollars, and it's working. So it's really cool. It's like it's physical detector that once the spring touches the metal that surrounds it, then it gives a buzz, or in our case, it gives a message to the person or the computer that analyzes the results. Of course, it should be a computer because it's in milliseconds, like the shock wave will get to this detector and then to that detector, but the difference would be in fractions of a second. Okay, so each rattle, okay, each ear or a detector will also have a mouth. Like the mouth is not like a buzzer. We don't want it to be, you know, calling the Hamas terrorists. We want it to send us a message. Okay, so when we are talking about sending us a message, it's literally, you know, an SMS or short message in the phone. Okay, so we have in Arduino again, Arduino. Remember, this is the brain, the controller of the system. We have a thing called Arduino SIM868. Sorry, Arduino SIM868. Okay, so this is what it's called, Arduino SIM868, and I'll write the description briefly because it's a long description. GSM, GPRS, GPS, Bluetooth, another word that I cannot understand. Oh, expansion board. Sorry, expansion board. GPS model SIM868, compatible with Arduino / Raspberry Pi, which is a more advanced computer, but also cheap. Like people buy both of them for enthusiastic teenagers to program and to learn electronics and, you know, maker skills. Send, this is part of the description in Amazon. Send, not in Amazon, yes, in Amazon. Send SMS, Bluetooth 3.0, 3.0 data. Okay, so we have a lot of standards or protocols that it supports. So I'll just write the protocols. GSM, GPRS, GPS, GSM, which is like cellular communications, GPRS, which is the same, GPS, which is, you know, the exact location, because you want to know, okay, you dropped it from an airplane, a bunch of them, but you want to know which one, like, okay, so the shockwave arrived to this specific detector, but where was it exactly? So in geographically, like, what is the coordinate? So it has GPS, it has Bluetooth, which I don't think is, well, maybe you want to make a system that has a redundancy, like if one of them gets destroyed or lost or malfunctions, then maybe they can pass the communication from one to the other. The most important part is that they are reliable. So each one of them is encrypted with a code that only is specific to that detector. And once it tells us, sends us the SMS, okay, SMS, and also Bluetooth. Bluetooth is good for 30 meters, but SMS you can send, like you do with the phone. Okay, Gaza is very close to Israel, so it can work on the Israeli cellular mobile network. So all these standards are useful for us. So GSM, GSM, GPRS, GPS, SMS, and Bluetooth. So if it sends us the SMS, we want to know exactly what time signature it was, so we know that it's not like some terrorist made it vibrate 5 minutes later to trick us. We want to know it's exactly in the microsecond that the blast happened, or like a few milliseconds after that. And we want to know that it's from that sensor and it's not fabricated, it's not, they don't cheat us. And also it's expandable. So after it's send us this one message in its lifetime, this whole unit, this whole ear plus mouth is, we don't listen for it anymore. Okay, we don't care about if they destroy it, if they steal it, if they recycle it, we don't care. Okay, and they cannot fool us because it's like it's encrypted with a code that only we know that it's authenticated and it's the correct message from our unit at that time, and we know it's reliable. Okay, so okay, so now after we understood how we map if we have like a bomb that is not in the right place, and we dropped a bomb, let's understand better the bomb part, because we want to make the bomb as close to the tunnel as possible. This is like the, now we are getting to the snake part. Okay, we said it's called Rattlesnake Armageddon. So the Armageddon we talked about, that we want to blow something from the inside, but we didn't say exactly what do we mean. And now we are talking about the snake. We talked about the rattle, the detector that detects the earthquake, the little earthquake that this shaking tunnel makes. But now we are talking about the snake part. Okay, the snake, just imagine how a snake bites. Okay, like a rattlesnake, like a viper. It has the fangs of the snake are acting like a syringe. Okay, it has a hollow inside, and the venom passes through the, like, it's like a syringe. Okay, it's like the venom doesn't flow outside of the tooth, outside of the fang. It flows inside the fang, like in a hollow tube. Okay, so this is very similar to what we do here. Okay, we just do it not with the venom, we are doing it with the water, and especially, like, specifically sea water, and we'll see why in a second. Okay, so now we are talking about the snake part. Okay, so we talked about the rattle, now we are talking about the snake. Okay, so imagine that we want to, we have a lot of sand. Okay, so this is the, I'll try to draw it for you. There are houses, and down here tunnel. And the surface is, you know, like 70 meters from the tunnel. Okay, I'm showing you the sketch. Okay, up here is the buildings, and you know, people live here, and down here is the tunnel, and it's like 70 meters. Okay, so how do we get, if we drop a bomb here and nothing happens to the tunnel, it's all this sand here, it's filled with sand. Let me show you the sand. Okay, so all the yellow part is sand. So it blocks if we try to make a bomb here, explosion, like drop a bomb from an airplane, then it stops here. It doesn't damage the tunnel is protected. So how do we do it? Okay, 41 minutes, I need to hurry. So what we do is we want to drop, it's called kinetic bombardment. So kinetic, but hear me out. I'm not trying to make like a bunker destroyer with the kinetic bombardment. It's not that. It's a lot more subtle. Okay, so kinetic bombardment. We need the water for what I'm doing. It's not like rods from the gods or something that the US invented. Okay, so it's not this weapon that comes from space with a titanium rod, like a telephone pole that smashes into the ground and directly into the bunker and cracks the bunker. It's not that. This is not the idea. Okay, so kinetic bombardment, I'm not getting into what it is. You can look it up there is also a nice video by Veritasium testing the US military's worst idea. Okay, testing the US military worst idea. Okay, by Veritasium, which is, you know, Veritasium is very smart, but this video is really like silly and stupid, and it's like it explains what it means, but it doesn't. He admits in the video that he made it like in a stupid way. So it's like, it's not that the idea is not good for us. It's just the idea is not good for what the US tried to use it originally, like using it against ICBM, against intercontinental ballistic missile, or against you know, like an ICBM. So that's not very useful, but it's also very expensive. But what we're doing from a chopper or a low airplane, not a low airplane, a chopper, a helicopter, then this is because it needs to be static for a little while, then it's good, like 100 meters above, and then it's ideal. Okay, so you just need to see what it means, but not be affected by the misleading title of worst idea, because for us it's a good idea. Okay, so any weapon, it depends how you use it. If you use it in a wrong way and you shoot yourself, for example, then any weapon is bad. Okay, so imagine we drop a rod. Okay, so we have a rod, like a cylinder, the hollow cylinder. Okay, try to show you a rod or a cylinder. And we drop it from a chopper. This is my attempt at drawing a chopper, and we are dropping a cylinder. Okay, the cylinder, sorry. This is the chopper, the helicopter, and the helicopter drops this rod, which is our unit. This is not the detector unit, this is the fang, the snake unit. And the fang drops into the ground and it stops, let's say, here. Okay, so let's say this is like, I don't know, like 2-3 meters. Okay, I cannot draw it to scale. This is 70 meters and this is like a few meters. Okay, so now what does the fang contain? The most important part of the fang is water and electricity in the form of batteries. Okay, like 9 volts batteries that you can buy in Amazon, also for the square batteries, also by Duracell you have it. Duracell copper top 9 volt batteries, sorry, $12 for a 4-pack. Okay, so the rod contains water, okay, you see, seawater, which is here. I cannot draw it. I can draw it, but it's like it should be very small. And once this hits the ground and stops, then the water percolates. Okay, so the water goes down to the tunnel and stops. The sand cannot stop the water, but the concrete or the metal stops the water, so the water would accumulate here. Okay, so when we hit the tunnel, we can create some small water deposit here. Where do the batteries come into play? Let's say we have the batteries. Let's put them in. I hope the purple works. It's an old marker. I hope it didn't dry out. No, it dried out. Let's use another color. Let's use orange because it's like the color of Duracell batteries. So let's say we have a battery. Okay, I didn't draw it very well, but okay, this is a 9 volt battery, and the unit has a lot of these batteries. So I'm drawing a small orange dots, but you understand that it's like 4 pack costs $12. So to get 100 batteries, it will cost us 12 times 25, which is $300. Okay, so we are this the unit is filled above the water. It has batteries, okay, connected to the two electrodes. Okay, so when this electricity, okay, so what we get here is sand which is wet. Okay, so this is like mud, wet sand, but this wet sand is a good conductor. Okay, normal sand is an insulator of electricity, but this wet sand is a good conductor. Okay, and because it's seawater, then it has salts in it, so it has good conductivity of electricity, and this acts like a ground. Okay, ground. So it's hard to write, it's not like I have my board. So what I try to write is ground. Okay, so I'm drawing in the direction of the electric current. The electric current will go like this. Electric current. The electric current goes like this and out of the water and into the ground. Okay, it goes in the path of least resistance, so it goes along the water because the water is very conducting and the sand is not. But once it reaches the big section of the water, it goes either to the tunnel, which is metal or ground, or just to the ground. Okay, but anyway, here there is a electric current, okay, from the batteries to here or to here. Okay, what happens when we get electric current? This is the heart of the system. What happens when we get electric current inside water? Okay, I'm sure you know, but I'm just making sure that everybody knows. When you have, it's called electrolysis. If you have, you can have a look in the, I don't want to waste time, so I'm just saying this. Electrolysis, it's another YouTube video. Electrolysis science experiment. Electrolysis is written like this. Okay, sorry. Electrolysis. And you can look in electrolysis science experiment of water and salt. Science experiment of water and salt. Easy science fair project for students. This is a YouTube video by Not. Sorry, Cont. Sorry, Cont. I know it's a funny name, but this is how this YouTube channel is called, and the video is nice. Okay, so this is the name of the video. If you don't know what electrolysis is, They use pencils and one battery. We use a lot of batteries, and our electrode is the water themselves. Okay, the water passes the current in our case. The wet mud, the wet sand, which is a good conductor. Okay, so if you get, I'm just showing you really quickly, if you have two electrodes, like if you have a battery and you have plus and minus, let's make the plus in blue and the minus in red. Okay, just to have some plus and minus. This is the two sides of the battery, and we make a connection here. The minus goes to here and the plus goes to here. I'll show you in 1 second. I just want to draw it in normally. Okay, so we have this is electrolysis in a nutshell. You have the battery, which gives you direct current, and you have this, the minus goes to here into the water, the plus goes to the other side in the water, and what happens, you will get bubbles, okay, and the bubbles will be the water splitting into oxygen and hydrogen, okay. It's more like ions of OH, which is oxide, and the H, which is hydrogen. But basically you will get the components of water, like oxygen and hydrogen, and the part with the hydrogen will get its H plus, so it will go to the minus. Minus and plus attracts. Here you will get bubbles of hydrogen. And here you will get bubbles of, for our sake, oxygen. As far as we're concerned, it's hydrogen and oxygen. Okay, you get a lot of bubbles which float, but they cannot float up to the surface where the buildings and the people are, because the sand locks them. Okay, it's not like in the experiment where they float and go to the air. Here there is sand, so they are locked very close to the tunnel. So you see the beauty of when hydrogen and oxygen are mixed. It's not flammable, it's also flammable, but it's like it makes an explosion if you get a tiny bit of electricity, which we have because the whole thing is made with electricity. So once the electricity gets in touch with the water, with the hydrogen, with enough hydrogen and oxygen, then it explodes. Okay, and it's very close to the tunnel. So you manage to get through all the, okay, we passed 1 hour, so I'll finish it, wrap it up. So we managed to get very close to the tunnel and to blow an explosion very close to the tunnel. Okay, so in this system, we use it to map. This is how we make the explosion very close to a tunnel. Right on top of the tunnel, the water percolates, get inside through the sand, sift through the sand, and gets through all the 70 meters that protects the tunnel until it gets to the close the tunnel, to the roof of the tunnel, and stuck. And then we explode with electricity the oxygen and hydrogen, and then we make the map with the things that here, the sensors, and after that we have a lot of options, like we know exactly where the tunnels are, and we can use a scaled up version of, you know, pumping. It's enough to pump even like only hydrogen into a hole, a small hole in the tunnel, and then once there is air in the tunnel because they want to breathe there, and once there is and to supply current, okay, with another system which is scaled up from this, and it can be a car, an armored car that is in the ground level that pumps in. Now we know exactly where the tunnels are, and once we pump enough hydrogen and the air mixture with the hydrogen and the normal air inside the tunnel can support an explosion, then it explodes the tunnel. Okay, so this is basically the heart of the idea, and this is the Armageddon of the tunnels, okay, because the blast wave will, the shock wave will propagate along the tunnels until it hits a door or something, but the tunnels are connected. So the shock wave will tell us with the detectors of the seismic activity where we need to go next and do the same process. Okay, so the same process helps us to destroy the tunnels and also to detect more tunnels. Okay, we drop from the airplane like for every one fang, for every snake part, we drop a few, many cheap rattle parts. So together it's the rattlesnake, and the Armageddon is what the Palestinians get, the Hamas terrorists get. Okay, so I hope you understood the you know, the main part, and that it saves Israeli lives. So thank you very much. Bye bye.